Some locomotives failed so badly in the 1950s that railroads stopped buying them almost overnight, quietly pulling them from service and pretending they'd never believed the promises in the first place. What looked powerful and modern in ads turned into breakdowns, smoke, and repair bills that no company could justify. These are 20 locomotives the industry practically banned without ever making it official. The American Locomotive Company built the FA series to go head-to-head with EMD's dominant F units in the freight market, and on paper the competition looked real. The FA-1 arrived in 1946 with 1,500 horsepower from Alco's new 244 diesel engine, and the FA-2 followed with a bump to 1,600 horsepower that was supposed to give railroads a reason to keep ordering. The 244 engine destroyed those plans before they ever had a chance. Crankshafts failed because the early versions were cast iron instead of forged steel, and even the forged replacements kept breaking under the stress of heavy freight service. The internal routing of fuel, lubricant, and water lines through the crankcase meant that any leak could contaminate the oil supply and wipe out bearings without warning. Turbochargers overheated and lagged behind throttle inputs so badly that massive plumes of black smoke became the signature calling card of every Alco locomotive on the road. By the early 1950s, buyers quietly shifted their orders to EMD, and Alco's market share collapsed. The company eventually replaced the 244 with the improved 251 engine in 1956, but the damage was already permanent. The FA series proved that a bad engine could kill an entire product line, and the next entry shows that Alco made the exact same mistake with one of the most beautiful locomotives ever built. Subscribe now so you don't miss the rest of these blacklisted machines. The PA series might be the best-looking diesel locomotive ever designed, with sleek, streamlined styling that made it the star of premier passenger trains like the Santa Fe Super Chief and the New York Central 20th Century Limited. Alco built 297 units across both variants, and every one of them carried the same cursed 244 engine that had already ruined the FA series. Oil consumption reached staggering levels, sometimes burning through 2 quarts per mile as internal leaks let fuel and water seep into the crankcase. Turbocharger failures caused power losses during passenger runs where schedule reliability actually mattered to paying customers. Most PA locomotives were retired by the late 50s, and several railroads rebuilt their units with completely different engines just to get some use out of the expensive car bodies. 6 PA units survive today, preserved largely because they were just too beautiful to scrap despite being too unreliable to operate. The PA proved that beauty couldn't overcome unreliability, and the next entry takes us to a company that tried to bring submarine technology onto the rails with even worse results. Fairbanks Morse had built wildly successful engines for Navy submarines during World War II, and the company was convinced that the same opposed piston technology would dominate the railroad market. The Erie built was a streamlined cab unit assembled at General Electric's factory in Erie, Pennsylvania, because Fairbanks Morse didn't have enough production capacity at its own plant. The opposed piston engine that had worked so well underwater struggled badly on land. Submarines benefited from cool sea-level air and abundant seawater for cooling, while locomotives faced high altitudes, desert heat, and radiator systems that couldn't dissipate enough thermal energy under heavy loads. The lower pistons ran dangerously hot during sustained operation, causing scuffing, liner damage, and the possibility of crankcase explosions. Maintenance required removing the roof hatch, disassembling the upper crankcase, and extracting the upper crankshaft before mechanics could even reach the components that needed replacement. Fairbanks Morse built 111 units before railroads stopped ordering, and every single Erie built was eventually scrapped. The Erie built showed that submarine engines belonged underwater, but Fairbanks Morse refused to accept that lesson and built an even more powerful version. The Trainmaster arrived in 1953 with 2,400 horsepower from a 12-cylinder opposed piston engine, making it the most powerful single-unit diesel locomotive available anywhere in the world. Starting tractive effort reached 112,500 pounds on 6-axle trucks designed for maximum grip. The opposed piston engine was sensitive to vibrations and frequent stop-start cycles that submarines never experienced, causing piston scuffing, lubrication failures, and thick clouds of white-blue smoke. The locomotive weighed up to 194 tons, which was too heavy for much of the existing 1950s track infrastructure, causing excessive rail wear and stress on bridges designed for lighter equipment. Accessing lower engine components required removing the entire upper crankshaft, a procedure so invasive that most shops refuse to invest in the training required to do it properly. Fairbanks Morse built only 127 units, and most American operators retired their trainmasters by the mid-1960s. Only Canadian Pacific number 8905 survives today at the Canadian Railway Museum in Quebec. The trainmaster had more power than any competitor, but couldn't stay running long enough to use it, and the next entry features a locomotive built with steam-era habits that doomed it from the start. Baldwin Locomotive Works had spent a century building steam engines and carried those habits directly into diesel production. The babyface earned its nickname from the rounded, stubby nose that gave it a distinctive appearance among 1940s freight cab units, but the problems underneath were far worse than the styling suggested. The 8-cylinder De La Verne 608SC engine was adapted for marine and stationary applications that operated under steady loads and controlled conditions. Railroad service demanded constant throttle changes, vibration absorption, and operation in dust and moisture extremes that the engine was never designed to handle. Baldwin produced each locomotive more like a custom steam engine than an assembly line diesel, meaning that wiring, pipes, and components were in different locations on different units. Only 33 babyface variants were built, and every single one was scrapped by the mid-1960s with none preserved. The babyface showed that Baldwin could not shake its steam-era habits, and the next entry proves that even a gorgeous redesign couldn't fix what was broken underneath. The Sharknose might be the most loved locomotive that mechanics absolutely hated working on. Its aggressive styling with a sloped shark-like front made it a photographer's dream, and Baldwin produced 109 cab units and 51 boosters between 1950 and 1953 for railroads including the Pennsylvania, New York Central, and Baltimore and Ohio. Underneath that striking body sat the same troubled De La Verne engine, now producing 1,625 horsepower. Crankshaft bearings scored and failed under variable road freight loads. Flexible hose connections leaked oil, fuel, and water that created fire hazards. When Baldwin exited locomotive production in 1956, parts availability vanished overnight. Most were scrapped by the mid-1960s, though 2 units survived with the Escanaba and Lake Superior Railroad in Michigan, still non-operational because of the maintenance challenges that doomed the class decades ago. The Sharknose proved that stunning looks could not compensate for an unreliable engine, and the next entry takes us to a switcher that started strong, but collapsed when its manufacturer disappeared. The VO 1000 was actually one of Baldwin's better diesel engine designs during its early production years starting in 1939, earning a solid reputation for reliable switching service with 548 units built over 7 years. Late production units from the mid-1940s inherited the broader problems spreading across Baldwin's diesel program, including wartime design freezes that prevented engineers from fixing known bugs and manufacturing variations that made each unit slightly different. When Baldwin merged with Lima Hamilton in 1950 and exited locomotive production in 1956, the proprietary De La Verne engine parts became impossible to source, forcing owners to cannibalize retired units or abandon the locomotives entirely. Several VO 1000s survive in museums today, a testament to the early units that actually worked before Baldwin's support infrastructure collapsed. Baldwin's exit left every VO 1000 owner stranded, and the next entry features another company that entered the diesel market so late it barely had time to fail. Lima Locomotive Works had been building legendary steam engines since 1869, and the company's desperate pivot to diesel power produced the LS 1200 switcher starting in 1950 with 69 units sold to railroads including the Baltimore and Ohio, Erie, and Nickel Plate Road. The Hamilton engine was advanced for its time with intercooling technology, but it produced excessive black smoke even at idle, and turbocharger maintenance costs ran higher than comparable EMD switchers. The November 1950 merger with Baldwin created Baldwin Lima Hamilton, which immediately discontinued Lima's designs. Parts support evaporated, and most LS-1200s were retired by the late 1950s. The LS-1200 arrived too late to build the support network it needed, The next entry is an even smaller Lima switcher that the market simply ignored. The LS1000 rolled out in May 1949 with 1,000 horsepower and 38 units built, including 5 demonstrators. The locomotive worked well enough in basic yard switching, and buyers like the Baltimore and Ohio found it mechanically capable for light duties. The problem was that EMD's SW7 and SW9 offered 1,200 horsepower with a nationwide parts network that Lima Hamilton could never match with such a tiny production run. The market essentially pretended the LS1000 didn't exist, and when the Baldwin merger killed Lima's diesel program in 1951, the few owners left had nowhere to turn for support. The LS1000 was ignored to death by a market that had already chosen its winner, and the next entry features a locomotive that failed not because of its engine, but because of everything built around it. The BL2 stands apart from every other locomotive on this list because its engine was actually excellent. EMD's proven 567B diesel produced 1,500 reliable horsepower that mechanics trusted, and the locomotive was designed to handle branch line service across roughly 80% of the American rail network. Everything else about the BL2 was wrong. The complex car body made engine access a nightmare, the cab windows created blind spots during switching, and the design lacked full-length exterior walkways that crews needed to move safely across the locomotive. EMD built only 59 units before replacing the BL2 almost immediately with the GP7, which fixed every problem and sold thousands of units. The BL2 failed as a design rather than a machine. The BL2 proved that a good engine and a bad body was still a bad locomotive, and the next 2 entries feature machines that were simply too small for the work railroads needed done. General Electric built the 70-ton switcher as a compact locomotive for light industrial spurs and branch lines with weight restrictions. The locomotive produced between 550 and 660 horsepower from a Cooper Bessemer diesel engine, which was adequate for shuffling a few cars around a mill or quarry, but woefully underpowered for anything heavier. Class 1 railroads had almost no use for it because EMD's SW series offered twice the horsepower with better tractive effort for busy yards where tonnage mattered. As freight volumes grew through the 1950s, the 70-tonner became obsolete on larger systems almost as quickly as it arrived, with units sold off to short lines and industrial operators. The 70-tonner was too small for the big leagues, and the next entry was deliberately designed to be even smaller for a reason that had nothing to do with engineering. The 44-tonner weighed exactly 44 short tons because of a labor agreement and nothing else. The 1937 deal between railroads and operating unions required a fireman on any locomotive weighing 45 tons or more. So, General Electric designed this locomotive to come in just under that limit for single crew operation. Twin Caterpillar engines produced roughly 380 to 400 horsepower, enough to move a handful of cars around industrial spurs, but nowhere near sufficient for real yard work. GE built 386 units before ending production in 1956, and the locomotive was reliable within its narrow role. As labor rules evolved and more powerful switchers became available through the 1950s, the 44-tonner's reason for existing gradually disappeared along with the loophole that created it. The 44-tonner was built around a labor rule rather than an engineering need, and the next entry brings us back to Alco and a locomotive that was popular despite inheriting the same engine problems that ruined 2 other product lines. The RS3 was supposed to be Alco's redemption after the FA and PA disasters, and it eventually delivered with 1,418 units sold between 1950 and 1956 to become Alco's best-selling diesel model. Early production units carried the same 244 engine that had destroyed the FA and PA reputation, suffering the same crankshaft failures, oiling contamination, and turbocharger breakdowns that mechanics had learned to dread. Alco spent millions on field repairs and upgraded the turbochargers multiple times before finally replacing the 244 with the improved 251 engine in 1956. Later RS3 units performed much better, but the early failures convinced railroads like Union Pacific to stop buying Alco products entirely, and the reputation damage followed the company for the rest of its existence. The RS3 survived its early problems through sheer volume, And the next entry takes us to a steam locomotive that was too advanced for the crews assigned to operate it. The T1 was the Pennsylvania Railroad's bold final attempt to prove that steam could outperform diesel in high-speed passenger service. Raymond Loewy designed its Art Deco streamlining, and Baldwin built 2 prototypes in 1942, followed by 50 production units between 1945 and 1946, with a duplex drive splitting power between 2 sets of 4 driving wheels for smoother high-speed operation. The T1 earned a reputation for violent wheel slip that terrified crews and damaged equipment. Improper spring equalization caused uneven weight distribution, and the rigid frame lost traction during acceleration on grades and over wet rail. The complex Franklin poppet valve gear required maintenance expertise that most shops simply couldn't deliver. Every T1 was out of service by 1952 and scrapped by 1956, some barely 5 years old, though the T1 Trust is currently building a new unit from original blueprints. The T1 was too demanding for everyday crews, and the next entry features a locomotive that performed brilliantly but was killed by corporate politics. The Niagara class might be the greatest passenger steam locomotive ever built, and the New York Central scrapped every single one anyway. Alco delivered 27 of these 484 locomotives between 1945 and 1946, and they performed exceptionally with outstanding fuel economy and the ability to run 15,000 miles per month with minimal maintenance on premier trains like the 20th Century Limited. NYC President Alfred Perlman made dieselization his top priority amid the railroad's financial crisis, ordering the entire Niagara fleet retired between late 1955 and July 1956. Every locomotive went to scrappers for under $15,000 each, despite costing roughly $248,000 to build barely a decade earlier. No preservation effort succeeded, and the Niagara class is completely extinct today. The Niagara was murdered by economics rather than engineering, and the next entry features an experimental machine that tried to reinvent steam power entirely. The M1 combined a coal-fired steam boiler with an electric turbine drive system in a package stretching over 106 feet long and weighing 607 tons. Baldwin built 3 units in 1947 and 1948 for the Chesapeake and Ohio's proposed Chessie Streamliner between Washington and Cincinnati. Coal dust and water infiltrated the traction motors and generators, causing electrical failures during test runs. Turbine blades cracked from thermal stress, and the boiler consumed up to 21,907 gallons of water per hour. The Chessie Streamliner was canceled in 1948 before it ever carried a passenger, and the M1s accumulated barely 20,000 miles each during experimental freight testing before all 3 were scrapped in 1950. The M1 tried to reinvent steam and prove that some technologies simply cannot be saved. And the next entry features locomotives that needed no reinvention because they were already among the finest ever designed. The J-Class consisted of 14 streamlined 484 locomotives that Norfolk and Western built in its own Roanoke shops between 1941 and 1950, and they were among the most reliable passenger steam engines ever constructed. They sustained speeds above 100 miles per hour while running 15,000 miles per month with minimal downtime, and their coal-burning efficiency benefited from cheap Appalachian coal that made steam economically competitive far longer than on most railroads. New President Stuart Saunders ordered full dieselization in 1958, and the J-Class went from active service to scrap metal in barely a year. Only number 611 survived because it happened to be in near-new condition after a 1956 rebuild, and it's since been restored multiple times for excursion service, most recently returning to operation in 2015. The J-Class was scrapped at the peak of its capabilities, and the next entry features another successful design forced out despite solving a problem no other locomotive could handle. The cab forward was one of the most ingenious solutions to a deadly problem in American railroading. Southern Pacific Sierra Nevada routes included long tunnels where conventional steam locomotives filled the cab with suffocating smoke and exhaust. By reversing the locomotive so the cab sat at the front and the firebox faced backward, crews could breathe clean air while smoke pushed behind them. Southern Pacific built 256 units between 1910 and 1944, and the later classes delivered over 124,000 pounds of tractive effort for heavy mountain freight. Diesel economics eventually caught up with even this successful design, eliminating the tunnel ventilation problem entirely while offering lower costs across every category. Southern Pacific retired its last cab forwards between 1955 and 1958, and only AC-12 number 4294 survives at the California State Railroad Museum in Sacramento. The cab forward solved its problem perfectly, but couldn't survive the economic revolution that made all steam obsolete, and the next entry features the largest steam locomotives ever built, facing the same inevitable end. The Big Boy was the largest and most powerful steam locomotive ever built for regular service. With 25 units constructed by Alco between 1941 and 1944 for Union Pacific's demanding mountain freight operations. Each locomotive delivered 135,375 pounds of starting tractive effort and hauled wartime freight with legendary reliability. Rising coal and labor costs combined with diesel technology improvements to make the Big Boys uneconomical despite their capabilities. The last revenue run occurred in July 1959, and most sat stored until official retirement in 1962. Union Pacific preserved 8 by placing them in museums, and number 4014 was restored to full operating condition in 2019 as the world's largest working steam locomotive. The remaining 17 were scrapped. The Big Boys were too large to justify in a diesel world, and the final entry brings us back to Fairbanks Morse and an opposed piston locomotive that proved the company never learned from its own mistakes. The H1644 was Fairbanks Morse's most successful locomotive model, with 299 domestic units produced between 1950 and 1963, but that success was relative to the company's other failures rather than any objective measure of market dominance. The locomotive offered 1,600 horsepower from an 8-cylinder version of the same opposed piston engine that had already earned a terrible reputation in the Erie Built and the Trainmaster. Every weakness that plagued the larger opposed piston locomotives showed up here at a slightly smaller scale. The engines demanded precise lubrication that degraded during idle periods, as oil drained from upper components and condensation caused corrosion. Carbon buildup blocked exhaust ports and caused rough running after any period of storage, and restarting an H1644 that had sat idle for even a few days meant hours of nursing the engine back to operating condition while EMD units fired up and went to work without complaint. Fairbanks Morse exited American locomotive production in 1958, confirming that the opposed piston engine never found its place on the rails despite decades of effort. 20 locomotives that the railroad industry quietly rejected across a single decade. Some failed because their engines couldn't handle the demands of daily service. Others failed because their manufacturers disappeared and left owners stranded without parts or support. Hit that like button now and subscribe for more stories about the machines that railroads tried to forget.